Okay, our next example says x minus 3 divided by x plus 1 is greater than or equal to 0. X minus 3 over x plus 1 is greater than or equal to 0. Everything is already set up the way that what we need. There's no algebra techniques that we need to do here. We basically are in a position now to where we actually use both of these expressions to help us find our test points. And experience and working a lot of problems, you'll be able to look right at a problem like myself and understand that there's no algebra here needed to do anything. You're already at a point now where you can solve for your test points and continue the problem. So in solving for our test points, we take all expressions and set them equal to 0. And this should be, again, obviously easy. If we take x minus 3 and set this equal to 0, it tells me that I would have a test point of 3. And if I take x plus 1 and set it equal to 0 and solve, it lets me know that I have a test point of negative 1. Dotted line, dotted line. I write both my factors, x minus 3 and x plus 1. And again, the techniques are very similar. All we do is we try points to the left of negative 2, to the left of negative 1, in between negative 1 and 3, and to the right of 3. A point to the left of negative 1, like negative 5, negative 5 minus 3 will produce a negative answer. Negative 5 plus 1 will also produce a negative answer. A point in between negative 1 and 3, the easiest choice is 0. 0 minus 3 gives us a negative answer, and 0 plus 1 gives us a positive answer. A point to the right of 3, like 5, 5 plus 3 gives us a positive, and 5 plus 1 also gives us a positive. So now we're dividing, so a negative divided by a negative still gives me a positive. A negative divided by a positive gives me a negative, and a positive divided by a positive gives me a positive. Now, I want to actually break, when we get ready to write our solutions here, I want to do it in two parts, meaning that I want to go and find all solutions that would first of all satisfy the inequality that says x minus 3 over x plus 1 is greater than 0, and then I want to come back and talk about what do we need to do for equal to 0. Okay, so again, this is what choosing our test points do for us. We see now that from negative infinity coming all the way into negative 1 will produce positive solutions. And picking up with 3 to positive infinity will also give us positive solutions. So if I put both of these numbers on the number line, negative 1 and 3, and right now I only want to use open circles because I'm only considering those solutions that are greater than 0. To depict this by picture, to talk about all solutions from negative infinity to negative 1, I need to go to the left. This illustrates that my solutions run from negative 1 all the way to negative infinity. And also to depict that I'm starting with 3 and going to positive infinity depicts that we draw an arrow to the right. Now we have to actually now consider the situation that gives me solutions that are equal to 0. This picture represents all solutions solutions that will give me a positive solution. But what about those that actually give me a solution of 0? Well, this is a fraction. This is a rational expression. And back in elementary school, we learned that fractions that give us an answer of 0 are those fractions that actually have 0 in the numerator, not the denominator. So the only value that will give us 0 in our numerator is the value 3. Because if x is 3, this says 3 minus 3, I've got 0 in the numerator. And I would have 4 in the denominator, but that's fine. 0 over 4 is 0. So the only solution that gives us 0 would be 3. So therefore I need to shade in my 3, and my 1 actually stays open.